In this video, we will be going over different problems of molarity, especially it will be helpful in your IAs, such that molarity, which is abbreviated as M, equals the moles of solute over the liters of solute. Molarity stands for molar concentration, in which molarity's units are moles over liters or moles over dm cubed. And we will be determining the number of moles of solutes in this problem that we'll start to solve, as we are given the molarity and the liters of solute, such that the given is 2.5 molar and 200 milliliter is the other given. But we cannot use milliliters in this equation. We will have to use liters, so we will convert it to 0.20 liters, as 1 liter equals 1,000 milliliters. And we will start by plugging in the 2.5 molar equals the moles of solute, which is unknown, so I'm just putting moles. You could put X, as that later on when you're crossing out all the units, you will be led to moles. So then you divide it by the liters of solution, which the liters are 0.20 liters. In order to only be left with the moles, you have to multiply 0.20 liters on both sides, that it cancels on the right, and you multiply it on the left. And since molarity is molarity over moles over liters, the liters will cross out and be left with the moles only. And it will be leaving you with an answer of 0.50 moles of solute, in which then we will be able to use the moles to deduce the amount of grams that will be needed in the whole reaction, as we want to figure out the grams of potassium carbonate. So we will start off by 0.50 moles of K2CO3, which is the whole chemical, over 1. And with our different pathways, it will be the molar mass over 1 mole. So the molar mass of K2CO3 is 138.205 grams of K2CO3 over 1 mole of K2CO3, in which we will be able to cross out the moles of K2CO3 and only be left with grams of K2CO3. Leading us with an answer of 69 grams of K2CO3. And since we started out with 2 sig figs, we need to end with 2 sig figs, so that's why we only have 69, though there are decimals. Going on to the second problem, we will be using a different equation this time. We will be doing molarity 1 times volume 1 equals molarity 2 times volume 2, as we want to determine the amount of milliliters of the second solution, as we want to dilute the solution. So we first are given the 6 molar HCl, and our second solution, we want to dilute it down to 2 molar, and we want to make a solution of 300 milliliters, but we'll have to convert that to liters, since in the equation we can only use liters, such that 6 molar is our M1, our 2 molar is our M2, as that's what we're trying to determine and dilute to. V1 we don't know, because that's what we're going to be diluting it down to, but we do know that we want a 0.3 liter solution. That's the amount we want. such that if we just want V1, we could just deduce the equation and be left with V1 equals M2 times V2 over M1, in which then we don't have to mess around with the numbers. We'll all be left with what the V1 is. So our M2 is 2 molar times the volume 2, which is 0.3 liters, over molarity 1, which is 6 molar. And the molar will be able to be crossed out, that we'll be left with the liters. So V1 will have an answer of 0.1 liters of, it will be water if you want to dilute it, the HCl. In this, in the equation, you could also like use milliliters. You don't have to convert it into liters, as you'll be staying constant and you will be measuring in milliliters. But since I converted into liters, now we will be converting it back to milliliters. So 0.1 liters over 1, and 1 liter equals 1,000 milliliters, giving us an answer of 100 milliliters. So to dilute the whole equation, you will be using 100 milliliters of water to get 2 molar HCl.